And welcome to the Daily Space Weather Show. We've got an uptick in solar activity since yesterday, an increase in sunspots, an increase in flaring, some more space weather headed Earth's way. We'll tell you all about it, and then some here at the Smash News Network. Least busted name. In news, this is a 24-hour video featuring ionized helium 304 angstroms from the Solar Dynamics Observatory, and I might attract your attention to the upper left, where we've seen a number of flares. Also, the center disk there, just south of the equator, you might see some activity kicking off as well. Some more coronal mass ejections to cover. Is there another one headed toward Earth? We'll let you know. But first, some additional sweet imagery of the closest star. Here we've added 193 angstroms and zoomed into that northeastern limb, where a new sunspot has risen and single-handedly increased the solar X-ray flux. So you might see some extreme brightening moments there, as that new sunspot has been quite active. Quite a lot of X-rays coming out of that zone. We will show you some more imagery of the closest star here. There is the SDO continuum. That is December 4th and December 5th to date. So a little bit of evolution happening in those south-central groups. A little bit of sunspot growth there. So looks like another uptick in sunspot number coming tomorrow unless some rapid degradation happens. There's colorized magnetogram for the same period, December 4th and December 5th to date. So that's a brief synopsis. And by the way, if you enjoy the content, consider becoming a member of the Smash team. You want email alerts because you're not getting notifications about videos like ours going up? Who ever heard of such a thing? Well, we've created solutions, but it's on you to utilize the solution. Smashomash.com/Smash Team is one of those. Get email alerts even at the bronze level. These videos brought to you in part by the silver and gold level Smash Team members. Shout out to them. Thanks for increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. The following are also paid endorsements, just like Smashomash.com/Smash Team. Our Hemp Lucid shop is one of our paid affiliates. You can find links below this video to help support the channel and perhaps help support your own health. What are people saying? Head to hemplucid.com, and on checkout, don't forget to enter the promo code SMASHOMASH10. Yes, SMASHOMASH10. It'll save you 10% on your CBDs for pets, your Delta 8s, your body balms and lip balms, your immune stress and sleep stacks, your mushroom gummies, and don't forget your CBD tinctures. Save 10% on all of those things by entering the promo code SMASHOMASH10 on checkout. Today's featured product from the Amazon shop is the Anti-Dentite Social Club. Are you an anti-dentite? Do you want to go show off to your friends and foes and show them what an anti-dentite you are? Well, I was wearing it on yesterday's video. If you'd like to wear it, it's now in the Spacewear collection at Amazon.com/shop/SmashoMash. You're a rabid anti-dentite, so why not show it off with the Anti-Dentite Social Club Novelty Tee? Also, you've got the Ask a Particle Physicist segment. If you want to get involved in the content by asking a particle physicist a question, we've got one in mind. It's the monotone from Minsk, Eugene Bagashov. So if you want to ask a particle physicist a question, the best place to do it is on the forum at smashomash.com/forum. Just scroll down to the General Science Forum, and that is where you can submit a question. It is Ask a Particle Physicist is the name of the thread. Just head there and add to the thread. The deadline is Thursday morning whenever I wake up. So that's when I submit the question, and by Friday, the segment appears. Most importantly, don't forget to subscribe to Eugene the Philosopher. Yes, Eugene the Philosopher. Yes, there is a T in Philosopher. So subscribe to his channel as he's blowing up. You want to get there on the ground level, folks. So head over there, check out some of his videos. perhaps about how thermonuclear fusion is a scam, or maybe stuff about YouTube, quote, content creating and things like that. So check it out. Eugene the Philosopher. Shout out to Eugene. He's on his way to 1,000 subscribers so he can monetize his channel. Help him out with that by becoming a subscriber to Eugene the Philosopher. Today's featured product from our channel is Keep an Eye on It. It's one of the taglines for the channel. So definitely, folks, keep an eye on it, okay? It's an intentional pun. Yeah, we'll keep an eye on it. And we'll provide sane daily space weather show coverage. And this handsome design, very high resolution imagery there in 171 angstroms from the SDO. You can get it up to 40% off on various different types of products. 35% off the Classic T, for example. It does feature our YouTube URL as well. We'll keep an eye on it so you don't have to, making it convenient for you to view your weather from space all the way down to Earth and in between. SmashOmash.com is the homepage. And welcome to the Neo Renaissance. Congratulations on Realize the channel exists. Visit us on social media. Press like, press share, etc. And let's get to volcanoes. So it looks like some auroral activity there near Fagradalsfjall, as we indeed have a green sky over Iceland. And let's see what volcanoes are erupting. Well, Krakatoa is on the list as it's producing some lava fountaining indeed. And here's the full list from volcanodiscovery.com. Starting out with Luatolo, which is exploding, producing a 16,000-foot ash plume. Krakatoa, 7,000-foot ash plume there. Again, lava fountaining episodes continue on the volcanic island, the daughter of Krakatoa, Krakatoa. Semeru also exploding. Flight level 140, 14,000-foot ash plume over East Java. Merapi exploding, 14,000-foot ash plume over western Sumatra. Dukono exploding, 8,000-foot ash plume over Halmahera. Emissions continue from Popocatépetl in central Mexico. Santiaguito exploding in Guatemala, 14,000-foot ash plume. Fuego in Guatemala, 14,000-foot ash plume. Not sure about Nevado del Ruiz, not sure about Sangay, but Sabancaya continues to erupt in an explosive fashion, producing a 26,000-foot plume of volcanic ash. It's a flight level, a 260 over Sabancaya in Peru. Please do not pole vault the caldera. Next, going to earthquake activity, and we saw a large quake in Hawaii, actually. So the largest in Hawaii in quite some time, and perhaps a little bit troubling there. That 5.1 occurring below the Kilauea complex. So there's the big island of Hawaii. There's where that 5.1 magnitude quake occurred. Under Kilauea, near the town of Volcano. We'll get to it. The earthquake capital of the world remains the Philippines at the moment, as many aftershocks occur there, like a 5.4 and a 5.1. The 5.1 at Hawaii occurred at 3:53 Universal Time this morning on December the 5th. So lots of aftershocks there at the Philippines continue. There was a 5.6 at Somalia there. So a 5.6 in East Africa. And then more quakes at the Philippines, like a 5.6, 5.4, etc. Indonesia had a 5.1 just south of the Philippines. Largest quake of the past 24 was a 5.8, I think. And Gulf of Aden also had a 5.4, that near the Somalian quake. And that is where the quakes end, and the space returns. So there's some space for you. 171 angstroms from SDO. And now the most likely place for a large flare is actually up in the northeastern limb. So just based on the statistical probability of what we've been having happening in the past 24 hours, that is the new place to watch for solar flares, the northeastern limb, which would be your upper left on that imagery. Next, let's get to some more stats. The 10.7 centimeter radio flux is now at 142 solar flux units. 142 is the radio flux number. There it is in the 1 year graph represented by the black line. Radio flux at 142. Coming up a little bit there as a result of that new sunspot. Space weather enthusiast dashboard here expecting some geomagnetic unrest tonight. So could see a mild geomagnetic storm. They're expecting it from coronal hole high-speed stream influences. There is a coronal hole high-speed stream continuing. We're actually seeing two different solar wind regimes here, which we will get to momentarily. First, the last 4 hours of Earth's magnetic moment from the space level. There is Earth to about 12 Earth diameters. It's Earth's magnetosphere, depicted by magnetohydrodynamic pressure. And we are having geomagnetically calm conditions right now. So, no major space weather coming in here despite the high-speed coronal hole wind stream. The magnetic field orientation is not lending to geomagnetic storm conditions. Here are the past 4 hours of Earth's magnetic moment from the ground. Again, it is calm here, so we're not having the most favorable conditions for auroral chasers. A sudden switch in the magnetic field orientation could change things quite rapidly indeed. Next, KP index 2.33 is the current KP index and average of global geomagnetism, 2.33 geomagnetically calm conditions, and here come the solar wind data. First, the ACE. The ACE showing even higher speed winds there than the Discover at 628 kilometers per second, but also quite diffuse at only 2 protons per cubic centimeter. Discover here showing some more interesting data actually, because we're seeing two separate solar wind regimes here. So you've got some plasma there at 470 kilometers a second, and then you've got a more significant signal there at 573 kilometers a second, but showing very diffuse solar wind there. So fast, but not dense is the current solar wind situation. 573 kilometers a second at the Discover. Also orbiting Lagrangian point 1. Next, the GOES magnetometers here, fairly smooth. So again, if we see a shift in the magnetic field, we could see geomagnetic storm conditions kick up quite rapidly. Next, our top view ecliptic plane field plot. You got to have it, folks. I mean, if you're not viewing the top view ecliptic plane field plot, you just aren't doing your space weather due diligence. So Earth is now in a North Pole-oriented sector of the heliosphere. Evidenced there by those blue potential field surface source lines. North Pole sector. Hey, welcome to the North Pole sector, folks. Here's our line of sight ecliptic plane field plot. And we can expect the North Pole sector to persist for several days. Here is our line of sight field plot. Here the solar polar fields are depicted in red and green for south and north. The gray depicts the photosphere magnetism, and the blue represents the solar B field, the field that goes through the magnet. It's kind of like a net of the polar fields to the extent that at which they overlap, which brings us to coronal holes. So here are coronal holes. We've got a number of North Pole-oriented coronal hole sectors here rotating in. Let's stop that at the last image. So the current situation is North Pole coronal holes are these, and these are South Pole coronal holes. So that is the current situation. Another 24-hour video from SDO. And let's get in a little bit closer here. There's the equatorial zoom. You may see some plasma reorientation happening down here, as there were at least 2 CMEs from that area. And we will cover that here in a bit. First, let's get to sunspots. Now that we've shown you all the details of magnetic fields and coronal holes and the brief view of sunspots, let's look a little more in depth into sunspots. There is the ROB, the Royal Observatory of Belgium. And just about where we forecasted those to be, a little bit higher actually than we forecasted, about 142 sunspots here The uptick forecasted yesterday indeed did come true. There you go. There's the data. And here's our flare probability monitor and scoreboard. Again, most likely place now for a large flare remains up here in the northeast. So that is the place to watch. That new sunspot hasn't even got a name yet. It's going to be known as 3513, I believe. 3513, we hope that one's called. And here come sunspots from the SDO. Here we've included 94 angstroms along with the SDO continuum to show active regions. Those sunspots in the south central region are also fairly magnetically complex, and they're looking a little bit volatile also, as they've been evolving in the past 24 hours. It'll be a little clearer with just the continuum, so let's switch to that. So a little bit of growth in those two twin sunspots. We've got two sets of twin sunspots there. I'm referring to these two groups right in here. Those are two very similar sunspot groups at very similar longitudes, I might add. So that's an interesting area indeed. And let's move to solar energetic particles and flares. So the ghost proton flux here, no spikes, but keep in mind if we do see a large flare, don't be surprised to see a major proton event. These become more likely during coronal hole high-speed streams. So far, still flatlined here. No spikes in the proton flux for an extended period. X-ray flux, like I said, has come up, and the background flux level is now probably something like a C2, or at least a C1.5. So big uptick there in X-rays in the past 24 hours, and it's all mainly due to one sunspot. So let's take a look at 131 plus 94 angstroms. And let's go to the T-mass, the most active sunspot. So that is definitely our T-mass of the day. The most active sunspot, 3513, not even named yet. It is overdue for a name. We won't be forgetting about that one anytime soon because it has been producing quite a bit of activity. Now, before we move on with more solar stuff, let's take a look at what's going on overhead. Here is our star chart. Just press the Now button once you've put in your location over at skyandtelescope.org. You'll see what's going on above your head. We've got a couple of gas giants up there over Lehigh Valley. Next, our solar system forecast. This is today. That's where things will be in a week. The new moon lies on the 13th. So the 13th of December is the new moon for this month. That is where things will be in a week on 12/12. By the way, if you enjoy the content, press the like button. If you're new to the channel, press the subscribe button. If you've already done those things, press the share button, leave a comment. And if you're mad that I'm asking for it, then leave a rage comment. We're terribly sorry that we have to advertise our own channel. However, you can blame YouTube for that. So press like, tell your friends and foes, and if you've got somebody who hasn't tuned into space weather, show them our shorts. They've been, shall we say, rather popular. Of course, in all seriousness, thanks to our YouTube subscribers, thanks to our new subscribers, and thanks most of all to the members of the Smash team. You can also follow us on Twitter, thanks to our, I think, 0 new followers over there on Twitter. And please don't delude yourself and suggest that censorship has somehow ended on social media. It's just as pathetic as it was in March of 2020, if not worse. x.com/smashomash for some content you can get no place else. So today's astronomy photo of the day is about the oh my god particle, the Amaterasu particle, not to be confused with the tiramisu particle, which is some sort of a coffee-flavored dessert. The Amaterasu particle is the second most energetic cosmic ray ever detected. So it created a massive particle shower. It was detected at 23 different detectors in the Utah desert. And you can find an article linked from the apod.nasa.gov website, apod.nasa.gov, is where to find the astronomy photo of the day. And basically what we're talking about here is cosmic rays. They're very hard to trace. They come from different locations, and as they snake their way through the universe, they get steered in all kinds of different directions as a result of magnetic fields. So that's, in a nutshell, what goes on. And what happens when they get to Earth's atmosphere is when they start to collide with things, they create particle showers. So they create all kinds of secondary particles which rain down, and those are all detectable without getting into the gory details of what happens. It does a thing like that which would be invisible to the naked eye, as these particles are moving at a significant percentage of light speed. When they start smashing into stuff in Earth's atmosphere, they start to slow down, lose energy, and create secondary particles. That's what cosmic ray detectors are detecting typically. And they even create things like isotopes. So that's the astronomy photo of the day. The Oh My God particle detected in Utah in May of 2021. So again, apod.nasa.gov is where to get that. And let's get into CMEs. So here are yesterday's CMEs. That is 95 frames from yesterday, December 4th. And we've also got today's frames. There's another 89 frames from today, and I think there may be another CME headed toward Earth, or at least with an earthly component. And it might actually be two. So let's not hang out on this too long. Let's add the Soho-Lasco C3. So multiple events here. There's one major one out of the west and southwest. There's one out of the northeast. And then there's a second event looking like it's coming out of the northwest, oddly enough. So let's take a look at this little closer view here. And that one out of the west, I believe, has an earthly directed component. So that showed up around midday. We can expect that to arrive late in the day on the 8th. Late day on December 8th, another CME impact. It'll be a glancing blow. It won't be a major CME impact, but it could cause some minor geomagnetic storm activity. And then right at the end, there's another event here that's looking like it's coming out of the northeast there, and that's just not enough info for me. So let's look at stereo A also. Here's where stereo A is located. Feel free to check out the Where is Stereo Today page. We show it daily just so people know where stereo A is located to help orient their view. Here's stereo A's raw coronagraph on the left and difference imagery on the right. So what do we have? What do we have? There's a great difference imagery of that major CME out of the southwest. Again, I think that one has an earthly directed component, and we'll show you here why in a moment. We've also got some pretty good viewing of that northeasterly event. Unfortunately, that data is a little bit older than the LASCO. And there we can see, okay, that's a little newer there. So you can see something happening there out of the northwest, right at the end. So here we'll stop the difference imagery on this large CME from the southwest. Great view of that. And let's switch to our custom coronagraphs. So here's a 24-hour video. There's SGO 193 angstroms in the center. Soho-Lasco C3 in blue, C2 in red. And as we get a little closer here, let's zoom in one notch. There we go. And you'll see some plasma perturbations right in here, just before that CME pops off out of the southwest. Now, that's right in the Earth-facing portion of the solar disk. That is why I think that there is an earthly directed component to that. So that's at least one CME headed this way, and I think there might even be a second. Let's get an even closer here. We'll drop the Soho-Lasco C3 and add 304 angstroms. So there's that first one. That looks like it's got an earthly directed component. And then right at the end, I suspect there may be another one that's even more earthly directed. So 2 CMEs expected to show up here starting late in the day on December 8th. That's my story, and I'm sticking to it. Here we've brought back just 304 angstroms by itself because it's time to switch to filaments. So filaments, there you go. Great view of filaments from Cerro Tololo, Spain, or Cerro Tololo, Chile, actually. And I suspect we're going to have to name one of these filaments here. Nobody's really doing it over on Twitter, x.com/smashomash. Follow the hashtag #NameThatFilament. I'm pretty sure I'm going to name that filament right there. And it may be named after a Kardashian. I'm not sure. It could be named after somebody in the realm of the Kardashians. I'll just say that. Cerro Tololo, Chile. Here's the grayscale imagery. And multiple prominences there. So there may be more sunspots hiding behind the northeastern limb. We'll keep you posted on that. In fact, we'll keep an eye on it, if you get my drift. So before we get to bonus features, let's show the GOES 18 SUVI. There you have it. And another CME is popping off as we make the video. So if you watch this area right here, you can see more plasma being released right there above the arrow. A great example of solar activity in action, in real time, while we create the video. Anyway, here come bonus features. Charging hazards are first. Satellite charging hazards are minor. They are of the surface charging variety there over the Middle East, the Western Indian Ocean, and Central Asia. GOES electron flux here coming up off the floor. Highest levels in a few days there from the GOES electron flux measured using radiography from the geosynchronous near equatorial orbits of the GOES 16 and GOES 18. There is the 1-year graph of the electron flux to contextualize that, still at quite low levels here, but not as low as they were. Forecast model showing it coming up, I would tend to agree. Those look like fairly reasonable forecasts represented by the green boxes. The yellow diamonds represent the observations. Next, we'll show the layer where it's measured, the F layer of the ionosphere. Here is the vibrational frequency of the bridge between Earth and space, courtesy of the Australian Government Bureau Meteorology. So that is raw megahertz. If that's gibberish to you, don't worry. We'll show the anomaly in megahertz from a 30-day median. But a brief synopsis is that it is geomagnetically calm conditions. And if you're waiting for the apocalypse, you're not going to get a signal for the apocalypse in the ionosphere, at least not in the previous day's activities. So there you go. If that frightens you, we suggest that you seek psychiatric help. Also, if every sunspot that forms or rises angers you, seek a psychiatrist for that as well. They're doing amazing things in mental institutions nowadays, folks. Here's the latest image. That's 2300 universal time ionogram, 2300 universal time anomalygram. We'll also show the WHAM, the whole atmosphere model. The global ionosphere nowcast depicting total electron content and anomaly on the left, maximum usable frequency and anomaly on the right. A great snapshot for both GPS users as well as radio operators. We'll also show total electron content by itself, free electrons to about 12,500 miles of altitude, the inner portion of the outer Van Allen belt. There are the free electrons between your GPS satellite and your handset. And we'll close out space weather with the latest high-res imagery of the closest star. So, there's the latest intensitygram. And there is the latest magnetogram. Do we have a new sunspot forming here to the south of this active group? And yes, we do. So sunspot number expected to continue to rise tomorrow. That could be as much as a 10 or 20 sunspot uptick in the sunspot number. Anyway, there's your full disk view. And it's time to move to meteorology. We're starting out things with mean sea level pressure, which is the color gradation, and surface level winds, which is the animation. So check it out. High pressure over Greenland, double low pressure in the North Atlantic, single low pressure south of Alaska. There is the Arctic Ocean. And if you think those pressures are low, check out what's going on east of the Drake Passage. There is the world's lowest pressure, I believe. That's about 950 hectopascals. Stormy seas there in the southernmost Atlantic Ocean. Anyway, there are the rest of sea level, mean sea level pressure and surface level winds. Let's switch to just the surface level winds. There you go. There's the eastern world's view. Shout out to our viewers from the east. Here are your jet streams. Here are the central world's jet streams. Shout out to our viewers from the central world. There are the surface winds for y'all. Here are the surface winds for the west. Jet streams of the Americas. Shout out to our viewers from this side of the map. And let's take a look at clouds and fog. There's what's going on for clouds and fog over the Americas. Here's a little closer view of all this moisture being pumped in from the Pacific. So a lot of warm water in the equatorial Pacific, creating a lot of evaporation, creating a lot of moisture, which is making its way into Washington and Oregon. So there is your atmospheric river. Shortwave radiation map depicting clouds and fog. It's the Pacific Express delivering a lot of H2O. So check it out. The forecast here is for pushing 7 inches of snow around coastal Oregon. That's the Euro forecast. The GFS forecast a little more mild. Only 4 inches, but that's still a lot. So between 4 and 7 inches of rain, folks, for the Pacific Northwest. And that's the next 3 days. So that's in addition to what has already fallen. So up to nearly 7 inches of additional rain forecast there. Next, our weather.gov map, and you'll see lots of flooding in the forecast there. Weather.gov is where to get your weather warnings. If your location is lit, click your location on the National Weather Service homepage. Here comes some forecasts, starting with the GFS 72-hour pressure and precipitation. So a lot of that moisture will turn to snow, and a warm front will make its way to the east. Going to get some unseasonably warm temperatures moving across the country. In fact, it's already started. Here is the total accumulated precipitation in inches. Same model, the GFS 72-hour. 72-hour GFS model showing precipitation, total accumulated precipitation in inches. Here is our accumulated positive snow depth change in inches. Same model, GFS 72-hour. And lots of snow here coming to California. Shout out to Smash Staff's mom, who will get a heapin' helpin' there. Also the Rockies. Parts of the Northeast also expecting some snow. West Virginia. Going to see over 6 inches in some spots there. That's your 72-hour GFS snow forecast. Here is your 72-hour GFS temperature anomaly forecast in degrees Celsius, as you see that extreme warmth making its way into Minnesota and into Wisconsin on its way to the Northeast. Some unseasonably warm temperatures coming. Next, our jet stream forecast, the real culprit for what's moving your weather from west to east, the jet stream, represented here by the 250 millibar winds. It's a 72-hour GFS model for the jet stream. Ta-da! Here's lightning for the past 10 hours. And here's a real-time lightning map from lightningmaps.org. Lightningmaps.org, powered by blitzachtung.org. Next time you hear thunder, check it out. convince the natives that you're Thor. Or, if you're over here, perhaps convince them that you're Zeus. I don't know, maybe that'll be more effective. There's some thunder rolling in the eastern Mediterranean. Current lightning strikes are at about 202 strikes per minute. And it's time to close this thing out with U.S. Doppler radar. Not for the full 50 state, for the lower 48. There you go. There is vertical motion in the air column. And there is clouds and fog. That's a shortwave radiation map, part of the NASA GOES Interactive Weather Satellite Suite. Here is the water vapor map as that moisture is making its way through the Dakotas, down toward Arkansas, as it makes its way to the east. So that's a scenario. Here is your recap U.S. Doppler radar. Clouds and fog. And there is your water vapor, and here is me closing things out. Since there's more space weather on the way, I've got to head back to the bunker because I've become spooked of space. I'm not sure if I should be frightened of an inactive sun or an active sun. So let us know in the comments. In the meantime, I'll be going back to the bunker again. Totally not entirely sure of what I should be horrified of. Hurrah.